Hello friends, we are going to start a lecture series on special theory of relativity, also called SR. This is lecture 1. In this video or lecture, we going to discuss three topics: inertial frame, postulates of special relativity and time dilation. First thing is inertial frame of reference. Inertial frame of reference means a frame of reference which holds Newton's law. Specifically, first law of Newton, law of inertia. So, inertial frame of reference which hold Newton's law. Newton's law. And their acceleration must be zero, means they are moving with constant velocity. Okay. Why we talking about inertial frame of reference here? Because the relativity calculations are correct or hold in inertial frame of reference only. Okay. Now we are going to postulates of special relativity. Postulates. There are two postulates of special relativity by Einstein. First one is law of physics. Law of physics are same in all inertial frame of reference. And the second one is reference. Okay. The second postulate is that velocity of light in free space is same in all inertial frame of reference. Okay, there are two postulates. First one is law of physics are same in all inertial frame of reference, and second one is velocity of light in free space is same in all inertial frame of reference. What is velocity? C equal to 3 into 10 power 8 meter per second. So up to this clear, right? What we learned, inertial frame of reference. What is inertial frame of reference? Which hold Newton's law and acceleration is zero and the constant, which is, they are moving with constant velocity. Then postulates of special relativity is that law of physics are same and velocity of light is same in all inertial frame of reference. So the next thing is time dilation, very important. Time dilation. If we consider a man is moving in an aerocraft. This is my aerocraft. I am very bad in drawing. A man is in aerocraft, okay, which is moving with a very high velocity comparable with velocity of light. Okay, two events are happened inside the aerocraft, and he measured that time interval and he denoted as T0. So T0 will be the proper time. Proper time is new word, right? Proper time. So proper time is the time interval measured by the observer in his own frame of reference. Okay, here the man is sitting in aerocraft and event also happened in aerocraft, so that time interval is proper time. Okay, and as second man, he is in the earth, he measured the time interval between the same two events that happened in aerocraft. and he denoted that is t. Okay, because of the relative motion, we found that t is greater than t0. T is greater than t0. T is the time measured by the man in earth, and t0 is a time measured by the man in aircraft. And it is found that t is greater than t0. This is called time dilation. Time dilation. Okay. Suppose, for example, if the time interval between here, let's say 3 seconds, then it will some 4 or 5, I don't know exactly, exact value will be gamma into 3. Okay, gamma into 3. Well, what is gamma? Gamma is 1 by root 1 minus v square. This is root 1 minus v square by c square. Gamma times this time will be the time measured by this man on earth. This is time dilation. The equation for time dilation is this one, gamma into t naught. T naught is proper time multiplied by gamma give t. Okay, next we are going to derive this equation. Very interesting. Okay, derivation of time dilation. Okay, that means all of you know this equation, right? T equal to gamma t naught, where t naught is proper time. Okay, this is proper time. What we are going to look is that how to derive this equation. First you need to consider a clock. Clock means this type of setup. Don't think about your digital clock. Okay, what we doing is that we send a light pulse, and this hit here and it will come back. This is one clock time. It will start from here and hit here and come back. This is one clock pulse. This type of clock is we are going to consider. Okay, so we are considering two clocks. One is at lab, I mean rest, and second is moving with velocity v. Okay, pictorially we can represent like this. At lab, I mean it's at rest, clock pulse light pulse is started from here and hit and start to come back and reach here. This is one clock pulse. Now moving frame. Similarly, three figure. Okay, when it is rest, the light pulse going in this vertically straight, but when it's moving, it will not go like this. It will go as slightly bended direction, and this figure is not that much clear. I'm very bad in drawing figure, so consider like this, and reach here and come back from here. After hitting here, come back and finally reach here. Okay, now consider the half journey. Means this distance you consider. Half journey means it reached here. Okay, this length is already L0. Here what we get, this is L0, so one clock pulse is T0, let's say called T0, which is equal to 2L0 by C. Why? time is distance by velocity. Here light has velocity c and distance how much? This L0 means 2L0, right? This get here. Now here we are considering half journey means we traveled consider from here to here, time is t and we consider t by 2 journey. So the light pulse reached here. So this distance is given by velocity into time. This is light. So light velocity how much? C into t by 2. This is given by this distance. This distance is c into t by 2. This distance will not going to change. This is L0. How much will be this? A clock is moving with velocity v. Something is moving with velocity v in time t by 2. Then how much is distance? All of you know, right? V into t by 2, right? You see? Okay. So this distance is how much? V into t by 2. So this is like a Pythagoras. This is like a triangle L0, and this is c into t by 2, and this is v into t by 2. Apply Pythagoras theorem. This square plus this square equal to this square. Simple. Now from this triangle by Pythagoras theorem we can write like this. Okay, v t by 2 square plus L0 square equal to c t by 2 the whole square. Okay, so L0 square is equal to c t by 2 the whole square minus v t by 2 the whole square. Now from this we can take t square outside. So c square by 2 square minus v square by 2 square equal to L0 square. So this can be written as t square into c square minus v square by 2 square L0 square. Okay, take this here and this become t square equal to 2 square L0 square by c square minus v square. Okay, take square root, then we get t equal to 2 L0 by root c square minus v square. Okay, then take c square from outside from here, then we get t equal to 2 L0 by c into 1 minus v square by c square. We know 2 L0 by c is what? T naught, proper time. So this time become t naught. So t equal to t0 by root 1 minus v square by c square. What is 1 by root 1 minus v square by c square? This is nothing but gamma. Okay, so we write this as gamma t0, t equal to gamma into t0. We got our required equation. Okay, now in next video we will discuss tin paradox and length contraction, etc., etc. So please subscribe this channel for more video. If you like this video, then please click on like button and share to your friend groups, etc. Okay.